Hello everyone, welcome to the Bharat Academy. I am Manoj Thapliyal and today's topic is hypothesis testing. Before starting hypothesis testing, we must have the idea of samples, populations, statistics, parameters. Now we start from the population. Population. This is also known as universe. Students, what is population? Population is the entire group of individuals under study, and this population may be finite or infinite. The population may be finite or infinite. We explain it by certain examples. Example: population of weight of students of class 12th in a school is the example of finite population. Since we can count all these students. Now the second example is pressure at different point in atmosphere is the example of infinite population. Since we cannot count pressure at different points in atmosphere. Now we take sample. A part of population is called sample. Now I explain this by this example. A housewife tests a small amount of rice to test whether it has been cooked or not from the cooker. This small amount of rice is your sample, which represents the whole amount of rice. The whole amount of rice will be population. Now the next is sample size. The number of observations in a sample is called sample size. It is denoted by small n. Now I take parameter. What is the parameter? A statistical measure computed from the population is called parameters. Population mean mu, population SD sigma, population proportion small p, and the population size capital N are called parameter. I take statistic. A statistical measure computed from the sample is called statistic. Sample mean x bar, sample st small s, sample proportions p, and sample size small n are all statistics. Now we come to the main topic, that is hypothesis. What is hypothesis? On the basis of sample information, we make certain decision about population. In taking such decision, we make certain assumptions. These assumptions are called Hypothesis. Hypotheses are just mere a certain assumption regarding population, or we can write it in another way. A hypothesis is a statement about population, about population means population mean, population variances, population proportions, and there are two type of hypothesis. There are two types of hypothesis. First is null hypothesis. Null hypothesis. In null hypothesis, it states that there is no difference. There is no difference between parameter and a specific value. Or we can say there is no difference. There is no difference between two parameters. Another way we can say it, the difference between two parameters. Two parameters is nil. That's why it is called null hypothesis. We can and this null hypothesis is denoted by H naught. Let us explain the null hypothesis by this example. If the cutoff score in GATE exam is 60 for mechanical engineering, a student Ayush also scores 60. What does it mean? It means there is no difference between the GATE score and the score achieved by Ayush. It means there is no difference between cutoff score and score achieved by Ayush. That is, we can write it null hypothesis as 0. The mu is equal to 60. Now the second hypothesis is alternative hypothesis. It states that there is a difference. Difference between parameter and a specific value, or we can say it like this: there is a difference between two parameters. It is just opposite of null hypothesis, and this alternative hypothesis is generally denoted by H1 or H alpha. Now I will explain it by giving an example. The example is if the cutoff score in GATE exam is 60 and a student Ayush could not score 60, then it's quite clear if there is a difference between cutoff score and the score achieved by student Ayush. And it is clear that if there is a difference. There is a difference between cutoff score and score achieved by Ayush. So we can write it like this. Null hypothesis H1 is mu population mean is not equal to 60. So this is the alternative hypothesis. Now what is this test of significance? The test which enables us to decide whether to accept or reject the null hypothesis. The null hypothesis is called test of significance. Test of significance. Students, in hypothesis testing, there are two types of errors. First is type 1 error. What is type 1 error? It occurs if one rejects the null hypothesis when it is true. It was true but it has been rejected. So this is type 1 error. I will explain it by this example. All knows the height of Amitabh Bachchan and height of Abhishek Bachchan are same. If the null hypothesis is like that, H naught height of Amitabh Bachchan equal to height of Abhishek Bachchan, and if this null hypothesis is rejected or this fact is rejected, so then it is an error. And this error is type 1 error. Type 1 error. Now the second type of error is type 2 error. It occurs if one accepts the null hypothesis when it is false. Now I will explain it by this example. If the null hypothesis is H naught is the height of Amitabh Bachchan is equal to height of Amir Khan. Everybody knows that Amitabh Bachchan is taller than Amir Khan. If this null hypothesis is accepted, it is an error. This error is called type 2 error. Now students, to determine when the null hypothesis is rejected, we select a level of significance and that level of significance I will explain. It is the maximum probability of committing type 1 error. Type 1 error. It is denoted by a letter alpha. Level of significance alpha means the probability of making type 1 error. Type 1 error. Generally we take alpha equal to 5%, 1% or 10%. If alpha is not given, we always take alpha equal to 5%. If alpha equal to 5%, it means there are chances of 5 out of 100 making type 1 error, and we can write it like this. Probability of making type 1 error, this is called level of significance alpha, and the probability of making type 2 error is called beta. Now we start two-tailed test and one-tailed test. I will explain it by this example. If we claim that the mean height of the student of the caste college is 65 cm, in this case the population mean mu is 65. Here we will form the null hypothesis like this. In this case the null hypothesis, the population mean is 65, then its alternative hypothesis H1 will be mu is not equal to 65. It can be less than 65 or greater than 65. It is two-tailed test. If H1 alternative hypothesis is taken, mu is less than 65, its null hypothesis automatically will be greater than equal to 65. Population mean will be greater than 65. This is, since mu is less than 65, this will be your left tail test. And if the alternative hypothesis H1 is taken, mu is greater than 65, its null hypothesis will be mu is less than equal to 65. So here the alternative hypothesis is greater than 65. In this case it will be a right tail test, and it's very clear the alternative hypothesis never contains equality, but the null hypothesis contains equality, and this alternative hypothesis determines the tail of the test. Now, how can we form these tail values, tail test? If the significance level alpha specifies the size of rejection region where the null hypothesis should be rejected, we call that region as rejection region or critical regions. In two-tailed test, the alpha is divided by 2 in two tails on both sides. In left-tailed test, the alpha is not divided and it lies in the left of the curve, and in this case the null hypothesis is rejected in the left tail, and in the right tail test the alpha is not divided and the null hypothesis is rejected in the right region. In two-tailed test, alpha is divided by 2. It means we reject the null hypothesis H0 in tails on both sides, and we do not reject it in the middle. From the graph it's quite clear that this portion is called non-rejection region and or non-critical region, and this shaded portion is called critical region. In one tail test, alpha is not divided, so the left tail test, the rejection region is in the left tail, and in the right tail test, the rejection region is in the right tail. Once the rejection region is set, we can calculate the test statistics. If the test statistics falls in the rejection region, we reject the null hypothesis H naught, otherwise we fail to reject it. Now students, there are certain steps in hypothesis testing. First of all, we form the null hypothesis. H naught is mu equal to mu 0, where mu 0 is the population mean, and then alternative hypothesis, just opposite of this null hypothesis, H1 will be mu is not equal to mu 0. Now the second step is test statistics. Test statistics are basically of two types, parametric test and non-parametric test. In parametric test, T test, Z test, F test are there. In non-parametric test, only chi-square test is there. The next step is degree of freedom. What is degree of freedom? Number of observations that are free to vary when certain restriction is placed in the data. Let n be the number of observations and a restriction is placed, then the remaining number of observations n minus 1 is your degree of freedom. Now the fourth step is level of significance, which is denoted by alpha. That we have to find level of significance in each test. Alpha is generally given if alpha 1% or 5%. If alpha is not given, so then generally we take alpha equal to 5%. And next step is fifth one, for given degree of freedom and level of significance. Level of significance alpha, we find the tabulated value of the test. Tabulated, or you call it critical value. Tabulated value of test statistic from given table of that statistics, that test. The sixth step is if calculated value of test statistic is less than equal to tabulated value, or you can call it critical value of test statistic, then the null hypothesis is accepted. But if calculated value of test statistic is greater than tabulated value or critical value of test statistic, then the null hypothesis is rejected. Now the lecture is over, but the student, if you have found this video interesting and helpful, please like it and subscribe my channel. Thank you for watching this video. Thank you very much.